Imagine standing on the starting line at the NHRA Winter Nationals in 1992. The air is thick with the smell of high-octane racing fuel and burnt rubber, a sensory assault that every drag racing fan knows by heart. You're used to the sound of Pro Stock engines. You know that deep, chest-rattling thrum of the 500 cubic inch big blocks from Ford and Chrysler. It's a sound that signifies brute force, a heavy artillery barrage of torque that twists chassis and shreds tires. But then, a car rolls into the burnout box that sounds wrong. It doesn't have that lazy, booming idle. It has a sharp, violent, almost metallic bark. It sounds like a chainsaw the size of a house. It's spinning idle RPMs that would make a normal race engine explode. The crowd goes quiet. The pit crews from the other teams stop wrenching. They walk to the edge of the asphalt, wiping grease from their hands, squinting into the sun. They aren't looking with admiration, they're looking with confusion, because what they are hearing is a small block Chevy. And according to every rule of physics, every textbook on internal combustion, and the entire engineering department of General Motors, the engine in that car shouldn't exist. It definitely shouldn't be competitive, and it absolutely shouldn't be making 800 naturally aspirated horsepower. This is legacy motoring, and I spend way too much time thinking about the golden era of naturally aspirated horsepower. If you're someone who obsesses over port velocity, volumetric efficiency, and the stories of the mad scientists who outsmarted billion-dollar corporations, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Look, I need you to understand the gravity of this moment. We aren't just talking about a fast car. We're talking about a moment where one man, working in a shop in rural Sugar Grove, Illinois, looked at the combined wisdom of the entire automotive world and said, "You're all doing it wrong." That man was Warren the Professor Johnson, and the engine he built didn't just win races, it broke the brain of every engine builder in the paddock. You see, in the early 90s, Pro Stock was a thinking man's game, but it was stuck in a box. The rules were strict. You had a 500 cubic inch limit. You had to use a production-based engine architecture, and critically, you could not use power adders. No turbos, no superchargers, no nitrous oxide. Nothing. You had to make power using nothing but atmospheric pressure and geometry. It was the purest test of engine building on the planet. And because of these constraints, everyone had converged on the same solution: big blocks. It was simple math, or so they thought. To make 500 inches, you took a big block architecture, which had massive spacing between the cylinders, and you bored it out. This allowed you to fit giant valves, which let the engine breathe. Now you might be thinking, why not just build a big small block? Well, here's the thing. The small block Chevy, for all its legendary status, has a fatal flaw when you try to push it this far. It's tiny. Specifically, the bore spacing, the distance from the center of one cylinder to the center of the next, is only 4.40 inches. In the engine building world, that is claustrophobic. When you try to stuff a 500 cubic inch displacement into that small frame, you run out of real estate. You can't fit big enough valves to feed the beast. If you put a valve that's too big in a cylinder that's too small, the edge of the valve gets too close to the cylinder wall. This is called shrouding, and it kills airflow. It creates turbulence, destroys velocity, and chokes the engine. It's like trying to drink a thick milkshake through a straw that's pressed against the side of the glass. It doesn't matter how hard you suck, nothing is coming through. So, for decades, the industry standard was clear. Small blocks are for street cars and Saturday night bracket racers. Big blocks are for Pro Stock. If you showed up with a small block, you were bringing a knife to a nuclear war. But Warren Johnson looked at the big block dominance and saw something everyone else missed. He saw inefficiency. Sure, the big blocks could breathe, but they were heavy. The rotating assembly, the crankshaft, the rods, the pistons, was massive. It took a lot of energy just to spin that weight up to speed. Johnson theorized that if, and it was a massive if, he could solve the airflow problem of the small block, he would have an engine with a lighter rotating mass, a shorter stroke, and a much more compact design. That engine would accelerate faster, rev higher, and be more aerodynamic than anything the competition had. But to do it, he had to do what GM engineers said was impossible. He had to make a small block head flow 400 cubic feet of air per minute. For context, a standard high-performance Corvette head from that era flowed maybe 200 CFM. He needed double that, and he had to do it without moving the cylinder walls, because the NHRA rulebook said he couldn't. Here's what most people don't realize about Warren Johnson. He wasn't a mechanic. He didn't learn to build engines by trial and error in a dusty garage. He approached engines like an aerospace engineer approaches a fighter jet wing. While his competitors were grinding metal and hoping for the best, Johnson was sitting in his office reading textbooks on fluid dynamics and thermodynamics. He understood that an engine is just an air pump. The more air you can process, the more fuel you can burn, and the more power you can make. But he also understood that flow numbers on a bench don't always translate to horsepower on the track. You see, most people obsess over peak flow, the maximum amount of air a port can move when the valve is wide open. But a valve is only wide open for a tiny fraction of a second. For the rest of the time, it's opening or closing. Johnson realized that if he could improve the low lift flow, the air moving when the valve is just barely cracking open, he could fill the cylinder more efficiently than a big block with massive valves that were lazy at low lift. This is where it gets really interesting. Johnson decided to throw out the rulebook on cylinder head design. He stopped looking at what Chevrolet had done and started looking at pure physics. He bought a computer-aided design system, back when most race shops didn't even have a computer. He started modeling port shapes that looked bizarre to the naked eye. Traditional wisdom said you want a big round port to move a lot of air. Johnson's data said no. He found that a smaller D-shaped port maintained higher air velocity. Think of it like a garden hose. If you put your thumb over the end, the water sprays further and harder. The volume is the same, but the velocity is higher. Johnson wanted that velocity to ram air into the cylinders at 10,000 RPM. He realized that if he could keep the air moving fast enough, the momentum of the air itself would force more oxygen into the combustion chamber even after the piston started moving back up. It's a concept called inertial supercharging, and while everyone knew about it, Johnson was figuring out how to weaponize it in a small block. But having the theory was one thing. Building it was another. The physical constraints were a nightmare. To get the valve sizes he needed, we're talking massive 2.30-inch intake valves. He couldn't use a standard valve layout. If he put them in the stock location, they would hit each other or hit the cylinder wall. So he had to redesign the entire geometry of the head. He had to move the valves, change the angles, and literally twist the combustion chamber to unshroud the airflow. This wasn't just porting a head. This was re-engineering the molecular structure of the engine's top end. He spent hundreds of thousands of dollars of his own money. He worked 18-hour days, sleeping on a cot in the shop. He was chasing a ghost. And that brings us to the part of the story where most people would have quit. You see, when you redesign a cylinder head that radically, you can't just call up a Foundry and ask for a few samples. You have to create the tooling. We are talking about complex sand cores, precise molds, and metallurgy that has to withstand the thermal shock of a drag strip pass. Johnson wasn't just an engine builder anymore. He was becoming a manufacturer. He had to convince foundries to cast his weird proprietary designs. He was asking them to put water jackets in places they said would crack, and to leave material in places they said would cause porosity issues. But Johnson didn't care about their manufacturing limitations. He cared about his airflow calculations. He pushed them, refined the molds, and rejected casting after casting until they got it right. This level of dedication is what separates the legends from the hobbyists. Most racers buy parts. Warren Johnson had to invent the process to make the parts he needed. Now let's talk about one of the biggest secrets to his success, something that even sophisticated racers often overlook: wet flow dynamics. See, a flow bench is a great tool, but it has one major flaw: it flows dry air. But an engine doesn't run on air, it runs on a mixture of air and fuel. And here is where physics gets tricky. Air is light, it likes to turn corners. Fuel is heavy, it wants to go on a straight line. If you design a port that looks great on a dry flow bench, but has a sharp turn right before the valve, the air might make the turn, but the fuel droplets will slam into the port wall, drop out of suspension, and create a puddle. A puddle doesn't burn, it just creates a rich spot and kills power. Johnson understood this better than anyone. He designed his ports with a line-of-sight approach. If you look down the intake runner, you could practically see the back of the valve. He raised the intake runners, straightening the path so the fuel would stay suspended in the airstream all the way into the combustion chamber. It sounds simple, but achieving this required offset rocker arms and a complete relocation of the push rods, which is a nightmare of geometry to set up correctly. This brings us to the valvetrain. the ticking time bomb of any high RPM pushrod engine. You have to understand that a pushrod engine is inherently messy. You have a cam lobe pushing a lifter, pushing a long metal stick, pushing a rocker arm, pushing a valve. It's a lot of moving parts, and they all have weight. When you spin an engine to 8,000 RPMs, those parts get heavy. The inertia tries to throw them apart. This is called valve float, and it's the engine builder's grim reaper. If the valve floats, it doesn't close when it's supposed to. It bounces off the seat. Or worse, it hits the piston. Boom, game over. The conventional solution was to just use stiffer valve springs. Just crush the system with pressure to keep it under control. But Johnson knew that massive spring pressure robbed horsepower. It takes energy to compress a stiff spring, energy that should be going to the rear wheels. So instead of just using brute force, he used stiffness. He obsessed over the rigidity of the push rods and the rocker arms. He used exotic tool steels and titanium components that were incredibly light but stiff as granite. He designed cam profiles that were aggressive but smooth, lifting the valve incredibly fast but setting it down gently to avoid the bounce. We are talking about controlling a piece of metal moving up and down 80 times a second with a precision measured in microns. His competitors were blowing up engines trying to hit 9,000 RPMs. Johnson was building a valvetrain that could sing at 10,000 RPMs and ask for more. This was the secret sauce. It wasn't just one part, it was the harmonization of the entire system. The bottom end of the engine was equally obsessive. He started with a GM bow tie block, which was a race-prepped casting, but by the time Johnson was done with it, GM wouldn't have recognized it. He spent days just detailing the block, smoothing oil return valleys to help the oil get back to the pan faster. Why? Because oil whipping around the crankshaft creates windage, a parasitic drag that can cost you 10 to 15 horsepower. He micromanaged the bearing clearances. While most people ran loose clearances to be safe, Johnson ran tight clearances with specialized thin oils. This reduced friction and improved stability, but it required an assembly precision that was surgical. If you were off by a 10,000th of an inch, the engine would seize. Johnson didn't use plastic gauge. He used micrometers that cost more than most people's daily drivers. Then came the moment of truth, the dyno room. Picture the scene. The engine is strapped to the water brake, the sensors are hooked up, exhaust gas temperatures, oil pressure, crankcase vacuum, fuel flow. Johnson's at the console. He hits a starter, the small block fires to life. It doesn't rumble, it zings. It sounds like a superbike engine magnified 10 times. He warms it up, checks the vitals, and then pushes the throttle lever forward. The engine screams. The needle on the tachometer sweeps past 7,000, past 8,000, past 9,000. Most big blocks would be wheezing by now, choking on their own airflow. But Johnson's small block is just waking up. It pulls cleanly all the way to 9,500 RPM. When he pulls the data, the numbers are staggering. 800 horsepower from 500 cubic inches. That is 1.6 horsepower per cubic inch, naturally aspirated. To put that in perspective, a modern Ferrari 458 Italia, one of the greatest engines ever made, makes about 1.27 horsepower per cubic inch. Johnson was beating modern Ferrari engineering in 1992 with a pushrod Chevy. But here's the kicker, and this is what really terrified the competition when they eventually saw the data. It wasn't just the peak number. Sure, 800 horsepower is great, but races are won by the area under the curve, the average power you make throughout the gear. Because of the small block short stroke and efficient heads, the power band was massive. A big block might have a power peak that lasts for 500 RPM. You have to shift perfectly to keep it in that window. Johnson's engine made killer power from 7,500 all the way to 9,500. It was a broad, flat plateau of power. This meant that on the track, if the driver shifted a little early or a little late, it didn't matter. The engine was always pulling. It was a forgiving weapon. However, a dyno sheet doesn't win races. A dyno sheet is just a promise. The real test is the drag strip, where variables you can't control come into play. Traction, weather, driver reaction time. When Johnson loaded that car into the trailer to head to its first national event, he knew he was walking into a lion's den. The Pro Stock pit area is a small village of gossip and judgment. Everyone watches everyone. When he unloaded the car, the whisper started immediately. Why does it sound like that? Is he running nitrous? There's no way that's legal. The tech inspectors were circling like sharks. They knew that if this car was fast, they were going to have to tear it apart. Johnson welcomed it. He knew exactly what was inside that engine, and he knew it was 100% legal. He also knew that he was about to embarrass some of the biggest names in the sport. The stage was set for a showdown that would fundamentally change the trajectory of drag racing history. The lights on the Christmas tree were about to drop, and the world was about to see what happens when you stop guessing and start calculating. The first qualifying session was a bloodbath. When Johnson's car left the starting line, it didn't leave like the big blocks did. Big block cars launch with a violent, chassis-twisting heave. They rely on massive torque to get the car moving, which often shocks the tires and causes them to spin or shake. Johnson's small block was different. Because it made its power higher in the RPM range, the launch was smoother. It was more progressive. The car just squatted and left. It looked deceptive, almost slow for the first 60 feet. But then, as the RPMs climbed, the power took over. By the 330-foot mark, it was flying. By half track, it was pulling away. And at the finish line, the scoreboard lit up with numbers that made the announcer choke on his words. He was running times that the top big block teams were struggling to hit on their best days. And he was doing it consistently, run after run. 6.90s, 6.90s, 6.90s. It was a machine. The aftermath was predictable chaos. The tech barn was swarmed. Competitors were filing protests before Johnson had even towed back to the pits. "Tear it down," they demanded. "Check the displacement. Check the fuel." The NHRA officials, feeling the pressure, ordered a complete teardown. They pumped the cylinders to check the displacement. Exactly 500 cubic inches. They checked the fuel, legal racing gasoline. They looked for hidden nitrous lines, illegal electronics, anything. They found nothing, just a beautifully machined, terrifyingly efficient small block Chevy. The silence in the tech barn was deafening. The other team stared at the disassembled parts, trying to figure out the secret. They looked at the heads, saw the strange port shapes, and scratched their heads. They looked at the valvetrain and marveled at the lightness. But they couldn't see the thousands of hours of flow bench testing. They couldn't see the cam profiles that lived in Johnson's computer. They were looking at the hardware, but they were missing the software, the intellectual property that made it all work. This is the part of the story where the David versus Goliath narrative usually ends. The underdog wins, the giants are humbled, and everyone goes home happy. But real life is more complicated. The giants don't just go home, they regroup, and they have deep pockets. Teams like Reher Morrison and Bob Glidden weren't going to take this lying down. They started throwing money at the problem. If Johnson could build a small block, so could they. The next few years became an arms race, the likes of which Pro Stock had never seen. Everyone was scrambling to develop high-flowing small block heads. The aftermarket exploded with new castings. Foundry technology advanced rapidly as demand for complex race parts skyrocketed. But here's the thing. They were all chasing Johnson's shadow. Every time they got close to his performance, Johnson would debut version 2.0 or version 3.0 of his heads. He was always one step ahead because he understood the why while they were just copying the what. Let's talk about the specific legacy of this engineering war. It didn't just stay in Pro Stock. The technology trickled down. You see, the principles Johnson was using, high port velocity, efficient combustion chambers, stable valve trains, applied to any engine. NASCAR teams started paying attention. They realized that they could make more power with smaller, more efficient ports too. The 18-degree Chevy head, which became the standard in oval track racing for years, owes a massive debt to the research Johnson did. Even the street car world felt the impact. The modern LS engine from GM, if you look at the port design, the valve angles, and the combustion chamber, you can see the DNA of Warren Johnson's race engines. The LS is basically a productionalized version of the lessons learned in Pro Stock during the 90s. Johnson proved that you didn't need a massive big block to make massive power. You just needed efficiency. But there was a human cost to this dominance. We often romanticize the obsessive genius, but we rarely talk about the toll it takes. Warren Johnson was a machine, but he was also a man. He missed birthdays. He missed holidays. His life was the shop and the track. His son, Kurt Johnson, eventually joined him in racing, and they became a formidable duo, but the pressure was immense. When you are the standard bearer, everyone is gunning for you. The NHRA, trying to keep the class competitive, started hitting Johnson with rule changes. They added weight to his car. They changed body style rules. They tried to slow him down. It became a game of whack-a-mole. They would penalize him, and he would just engineer his way around it. Add 50 pounds to the car. Fine, he'd find 10 more horsepower to compensate. It was a relentless grind that would have broken a lesser competitor. Now, you might be wondering, if this small block was so good, why do Pro Stock cars today use engines that look like big blocks? Well, that's where the evolution of the rules comes in. Eventually, the NHRA relaxed the rules on bore spacing and deck height to the point where the distinction between small block and big block became blurry. Today's Pro Stock engines are custom-built, purpose-designed monsters called DREC, or Drag Racing Competition Engine, blocks. They have bore spacings that are even wider than the old big blocks. But, and this is critical, the design philosophy is pure Warren Johnson. They prioritize airflow efficiency, valvetrain stability, and high RPM over sheer displacement, which is still capped at 500 CI. They are the spiritual successors to that little 800 horsepower Chevy. Here's something most people don't realize about the financial side of this era. Johnson didn't hoard his secrets forever. He was a businessman. Once he had developed a newer, better design, he would sell his old engines to customers, and people paid fortunes for them. We're talking $80,000 for a used engine in 1994. That is house money. But the racers paid it gladly because a used Johnson engine was still faster than a brand new engine from anyone else. It created this weird ecosystem where Johnson was beating his own customers with his new stuff, while his customers were beating everyone else with his old stuff. He effectively controlled the entire field. At one point, half the qualifying field was running some form of Johnson technology. He wasn't just a racer, he was a supplier for the entire class. Let's dive a bit deeper into the electronics because this is another area where Johnson was light years ahead. In 1992, data acquisition was in its infancy. Most teams relied on the driver saying it felt a little loose in third gear. That is useless data for an engineer. Johnson retrofitted his car with sensors that were usually found on industrial machinery. He had strain gauges on the suspension, accelerometers on the chassis, and oxygen sensors in the exhaust collectors. He built his own wiring harnesses. After every run, while other drivers were signing autographs, Johnson was staring at a DOS-based computer screen, analyzing graphs. He could see exactly where the clutch was slipping. He could see if cylinder number 7 was running 1% leaner than cylinder number 5. This allowed him to tune the carburetor jetting for individual cylinders, something nobody else was doing. He was tuning with a scalpel, while everyone else was using a sledgehammer. This data-driven approach allowed him to make calls that seemed crazy to others. For example, he might change the gear ratios in the transmission based on a change in barometric pressure. If the air density dropped, he knew the engine would make slightly less power, so he would swap to a shorter gear to keep the RPMs up. It was this level of granularity that won him championships. He wasn't guessing, he was executing a mathematical formula. But perhaps the most fascinating aspect of the Johnson legacy is the psychological warfare he waged. He knew his competitors were watching him. He knew they were obsessed with his secrets. So sometimes he would feed them misinformation. He was known to leave decoy parts on his workbench when he knew snooping eyes were around, camshafts with profiles he never intended to use, or cylinder heads with bizarre port modifications that didn't work. He would let the rumors swirl. Did you hear Johnson is experimenting with ceramic lifters? I heard he's running a new firing order. The other teams would waste weeks chasing these red herrings, spending money and time testing theories that Johnson had already discarded or invented just to distract them. It was 40 chess played at 200 miles per hour. He understood that if he could keep them confused, he could keep them behind him. This psychological dominance extended to the starting line. Johnson was known for his stoicism. While other drivers would get pumped up, shouting and banging on the steering wheel, Johnson was ice cold. He sat in the car like he was waiting for a bus. His heart rate barely elevated. This calmness allowed him to cut incredible reaction times. In Pro Stock, where races are decided by thousandths of a second, the driver is just as important as the engine. You can have the most horsepower in the world, but if you sleep at the light, you lose. Johnson was a robot. He would stage the car, hit the shift points perfectly, and drive the car straight down the groove every single time. His consistency was demoralizing. You knew that if you were lined up against WJ, he wasn't going to make a mistake. You had to beat him. He wasn't going to beat himself. Let's take a moment to appreciate the sheer durability of these engines. In drag racing, we accept that parts break. Top fuel engines explode every run. Even Pro Stock engines are ticking time bombs. But Johnson's engineering philosophy prioritized survival. He knew that to win a championship, you had to finish races. A DNF, did not finish, is 0 points. His engines were over-engineered for reliability. Because he used lighter components and controlled the valvetrain so precisely, his parts didn't fatigue as quickly. He could run an engine for multiple events without a rebuild. This gave him a massive logistical advantage. While other teams were thrashing in the pits, swapping engines between rounds, Johnson was refining his tune-up. He was resting. He was analyzing data. This efficiency meant his team was less stressed, made fewer mistakes, and was always ready for the next round. It was the tortoise and the hare story, except the tortoise was also the fastest thing on the track. The 1993 season stands as the ultimate testament to this. Johnson won 10 national events that year. 10 in a professional class where winning one is a career highlight for most people. He clinched the championship with ease. At the U.S. Nationals, the Super Bowl of drag racing, he didn't just win, he set the national record for both elapsed time and speed. He ran a 6.98 second pass, breaking the 7-second barrier at a national event. That is a milestone akin to breaking the sound barrier. It was a psychological blow to the competition that took years to heal. It proved that the small block wasn't a fluke. It was the future. It forced the entire industry to acknowledge that the era of bigger is better was over. The era of smarter is faster had begun. Now let's fast forward to today and look at the engine landscape. You walk into a modern engine shop, say for a high-end bracket racer or a grudge car, and what do you see? You see 15-degree heads. You see spread port exhaust flanges. You see shaft mount rocker systems. You see belt drives for the camshaft. All of these are standard now, but in 1992, they were exotic. Johnson normalized the exotic. He took technology that was reserved for Formula One and IndyCar and brought it to the grassroots world of door slammer drag racing. He showed that you could apply high science to a cast iron V8, and in doing so, he elevated the intelligence of the entire sport. He forced mechanics to become technicians. He forced drivers to become engineers. He raised the bar so high that if you didn't evolve, you went extinct. There is a beautiful irony in the fact that the engine which caused all this disruption sits in a museum today. It looks unassuming. It's just a block of metal with some aluminum heads bolted to it. It doesn't look like a revolution. But if you know what you're looking at, you can see the genius. You can see the port angles. You can see the external oil lines. You can see the custom intake manifold. It is a monument to human ingenuity. It's a reminder that impossible is just a word people use when they haven't done the math yet. It reminds us that innovation doesn't always come from the biggest companies with the biggest budgets. Sometimes it comes from a guy in glasses standing in a shop in the middle of a cornfield, refusing to accept the status quo. But wait, here's what gets really interesting about the cultural impact. Johnson didn't just change the cars, he changed the fan base. Before him, Pro Stock fans were brand loyalists. You were a Ford guy or a Chevy guy or a Mopar guy. You cheered for the badge on the grill. But Johnson created a new type of fan, the technology fan. People started cheering for him not because he drove an Oldsmobile or a Pontiac, but because they respected the engineering. He transcended the tribalism of the manufacturers. He became the patron saint of gearheads who loved the process of making horsepower. He proved that you could be a nerd and a badass at the same time. He made intelligence cool in a sport that was often stereotyped as simple. And we have to talk about the professor nickname. It wasn't just marketing. Johnson literally lectured. He would hold seminars. He would talk to the press and explain in excruciating detail why the air pressure under the car was affecting his top speed. He didn't dumb it down. He treated the media and the fans as if they were capable of understanding the physics. And guess what? They learned. He raised the IQ of the entire drag racing community. Writers had to learn about fluid dynamics just to interview him. Commentators had to learn about suspension geometry to call his races. He educated the sport while he was dominating it. So when we look back at the legacy of the 800 horsepower small block, we aren't just looking at a mechanical achievement. We're looking at a paradigm shift. We're looking at the moment when drag racing moved from the analog age to the digital age. We're looking at the triumph of mind over money. And that is a story that resonates far beyond the drag strip. It's a story for anyone who has ever been told that their idea won't work, that they don't have the resources, or that they should just stick to the conventional way of doing things. Warren Johnson didn't listen to the noise. He listened to the data. And the data told him he could win. So why does this story matter to you right now in 2026? You might be sitting in your garage looking at an LS swap project, or maybe you're just a fan of automotive history. Why should you care about a guy from the 90s and his obsolete small block? Here's the thing. Warren Johnson's story is the ultimate validation of the garage engineer. It proves that you don't need a multi-million-dollar budget to innovate. Sure, Johnson spent money, but he didn't outspend GM. He outthought them. In an era where we're used to bought horsepower, where you can just order a 1,000 horsepower crate engine online or bolt on a twin turbo kit and make 4 digits, there is something incredibly pure about what Johnson did. He didn't force the air in, he invited it in. He seduced the laws of physics rather than breaking them. There's a lesson here about the difference between assembling and building. Today, we've become a culture of assemblers. We buy the best parts, we bolt them together, and we expect a result. But Johnson taught us that the magic happens in the margins. It happens in the clearances. It happens in the specific angle of a valve seat that you cut yourself. It happens in the port matching that you spend 40 hours doing by hand. If you want to build something truly special, something that stands out from every other car at the meet, you have to adopt the Johnson mindset. You have to stop looking at the parts catalog and start looking at the system. You have to ask, how does this camshaft interact with this intake manifold? Not just how much horsepower does it promise. Think about the sheer audacity of the numbers one last time. 1.6 to 1.7 horsepower per cubic inch, naturally aspirated, with push rods, with a carburetor. There are modern overhead cam, direct injected, computer-controlled engines from major manufacturers that don't hit that efficiency. That isn't just a testament to racing, it's a testament to the potential of the internal combustion engine when it is optimized to its absolute limit. Johnson showed us that the limit is much further out than we think. He proved that the limit is usually just a lack of imagination or a lack of effort. And his legacy lives on in the people he trained. Look at the current Pro Stock field. Greg Anderson, one of the winningest drivers in history, started as Warren Johnson's crew chief. He learned the system. He learned the discipline. The Johnson tree of engine builders and crew chiefs has spread throughout the sport. Every time you see a naturally aspirated car run a number that shouldn't be possible, there's a little bit of Warren Johnson's DNA in that run. He didn't just build engines, he built a school of thought. He created a lineage of obsessive perfectionists who keep pushing the envelope. It is also worth noting that Johnson never really retired from the intellectual pursuit. Even after he stopped driving, he kept developing, he kept consulting. Because for him, the puzzle was never solved. An engine is never done. There is always a little more efficiency to find. There is always a way to reduce friction just a little bit more. There is always a better burn pattern to be found in the chamber. That is the curse and the blessing of the true engineer. You're never satisfied, but you're never bored. So, the next time you hear a choppy idle at a stoplight or you see a Pro Stock car launch on TV, I want you to remember the secret small block. Remember the panic it caused. Remember the chaos in the tech barn. Remember the sound of a 500-inch engine spinning to 9,500 RPM and holding together through sheer force of will and mathematics. It stands as a beacon for all of us who love mechanical things. It tells us that if we dig deep enough, if we learn enough, and if we are willing to do the work that others won't, we can achieve the impossible. We are living in a time where the internal combustion engine is being threatened. Electric motors are taking over, and that's fine. Progress is progress. But there is a soul in a naturally aspirated race engine that a battery can never replicate. There's a complexity, a vibration, a literal breathing quality to it. Warren Johnson mastered that breath better than anyone in history. He took a pile of iron and aluminum and gave it a voice that screamed defiance at the biggest corporations in the world, and he won. If you are working on a project right now, whether it's a race car, a restoration, or just something to cruise in, take a page from the professor's book. Don't just throw parts at it. Think about it. Visualize the airflow. Understand the friction. Build it with your brain, not just your wallet. Because at the end of the day, the guy with the biggest budget doesn't always win. The guy who knows why it works wins. I hope this deep dive into one of the greatest engineering feats in motorsport history has inspired you to look at your own projects a little differently. If you enjoyed this breakdown of the impossible 800 horsepower small block, and if you want to see more stories about the legends who shaped the world of high performance, you know what to do. Hit that subscribe button so you don't miss the next deep dive. Drop a comment below and let me know. Do you think we will ever see an era of innovation like 1990s Pro Stock again? Or are those days gone forever? I read every comment and I want to hear your take. This has been Legacy Motoring. Keep wrenching, keep calculating, and never accept impossible as an answer. I'll see you in the next one.